is the energy associated with the formation of 1 mole of a substance from its elements in their standard states. Standard states mean what state they are at room temperature. What state they are at room temperature. So, for example, if you form carbon dioxide from its elements in their standard states, there is an energy change associated with that, and 393.5 kilojoules of energy is released per mole for the formation. So, to write the thermochemical equation, you can only have 1 mole of product. So if when you balance your chemical reaction, there's a number other than 1 in front of your product, you have to divide. So this is where you might get fractions of a half. Okay? That's the rule. It has to be written for 1 mole of product. You write the reactant elements in their standard states, and the coefficients represent, so you've got to make sure that you've balanced it correctly. So if we look at carbon plus oxygen to form carbon dioxide, is that balanced? Yeah. So we're good for that one. Hydrogen plus oxygen to make water liquid has an energy change of minus 285.8 kilojoules. So energy is released. And then for water vapor, you release 241.88 kilojoules. So do you remember, I think I asked you whether or not you had high efficiency furnaces at home? This is what happens for this high efficiency furnace. It burns the natural gas, produces water vapor, which releases 44 kilojoules of energy less than water liquid. You get that energy out of it by condensing the gas into a liquid. But of course you have to have a drain go into a sink or a drain to get rid of the water. So, benzene. What's the formula for benzene? Molecular formula. C6H6. Now benzene happens to be a liquid, but I wouldn't expect you to know that. Benzene is a liquid. All right. What elements make up benzene?
Carbon and hydrogen.
Carbon. How do you write hydrogen as an element?
H2.
Oh, good. So balance that. All right. Now, I haven't given you the enthalpy of formation, but you're going to look it up. So if you put it as a delta H, it goes on the end. What side do you put it on if it goes in your thermochemical? Yeah. Left side, yeah. All right, try the next one, potassium chlorate. How do you write potassium as an element? It's just potassium. So you want to tell us what you got?
2 potassium plus CO2 plus 3 O2. 2 KCl. And then delta H equals.
What's wrong with this? Brandon?
The product should be 1 mole.
Yeah, the products are 1 mole. So now go through and divide everything by 2. It's all right. You can do this and then do exactly this. So now it's 1K plus half a chlorine plus 3/2 oxygen. And what is your delta H? What does the table say on page 318?
Not on it.
Uh-oh, it's not on there. So it's got to be somewhere else in your book.
Page 743.
Page 743 in your appendices. Your textbooks will always have tables in the back, in the appendix. So Emily, what's the number? It's not alphabetical.
Negative 397.7.
Beautiful, thank you. All right. What's the thermochemical equation for the formation of ethanol? Waleed.
2C plus 3H2 plus half O2 creates ethanol.
And what is your delta H?
Negative 277.6 kilojoules per mole. Or sorry, kilojoules.
Kilojoules, okay, just checking. So, don't forget, you can only put kilojoules in your thermochemical, and then magnesium hydroxide.
I did magnesium and then plus O2 plus H.
Yeah. And what is our delta H?
Negative 924.25 kilojoules.
Wow. That gives off a lot of heat. So by using enthalpies of formation, we can find enthalpy of reaction for a specific reaction, but we can also find an enthalpy of formation that's not in your textbook if they give us the enthalpy of reaction. So there's two things you can find using this formula. So what does this formula mean? Jackson.
The sum of the enthalpy of formation of the products minus the sum of the enthalpy of formation of the reactants equals the change in enthalpy.
Yes, but there's a typo in this that I just see now. Can you add in moles? So delta H is equal to N delta HX. So delta H for the reaction is the sum of N delta HF for your products. Subtract N delta HF for the reactants. I'm missing a moles. So we take the enthalpy change for the products and we subtract from it the enthalpy change for the reactants. And we figure out then the enthalpy change for the whole reaction. All right, so we're going to do this example together. What is the enthalpy change for the complete combustion of ethanol? So first thing you need to do is write out a balanced chemical equation. So we are burning ethanol. So what is our other reactant? Oxygen. Now, This is where subscripts count. Do we want to make water vapor or water liquid? When it burns, initially you make water vapor. When it cools down, you get water liquid. Which one do you want to pick? Because if it doesn't tell you in the question, you pick one.
Liquid.
Liquid, okay. So we're going to make H2O liquid and carbon dioxide gas. And we want to know, what is our delta H? For this entire reaction. So balance this.
Is it?
Because you would have 7.
For everything.
2, 2?
Or
No.
1.
Oh, yeah, there's.
So that gives us 4, 7, 6, 6. Okay, beautiful. All right. Now, we're going to use this formula to figure out. So delta H is going to be equal to, so we take our products first. So we have 3 moles, you take the coefficients, times delta HF of liquid water, plus 2 moles times the delta HF of CO2. From this, you are going to subtract the sum of 3 moles times the molar enthalpy of formation of O2 plus 1 mole times the molar enthalpy of formation for ethanol. So let's find those values on page 743.
No clue.
No clue? What do you,
-2.
how can it be not there?
Wait, oxygen.
Oxygen, O2.
Oh, is it gonna be, wait, what's the one here? No, specific heat gas.
Huh. Can't just not be there. There must be some piece of information that's there. Maybe above or below the table? It's 0. How do you know that?
Oh, there you
Says right there.
Says right there. Note. So if you have an element in its standard state, it's 0. So 3 moles times 0. And then we have the molar enthalpy of formation of oxygen. Ethanol. That's interesting. What is it for C2H5OH?
It's -277.6 kilograms per mole.
All right, now you can start calculating.
please?